Good morning. Presenting a short video on federated databases. What are federated databases? A federated database system is a type of metadatabase management system or DBMS which transparently maps multiple autonomous database system into a single federated database. The constituent databases are interconnected via computer network and may be geographically decentralized. Since the constituent database system remain autonomous, a federated database system is a contrastable alternative to the sometimes daunting task of merging several disparate databases. Characteristics. Federated databases have three main characteristics: distribution, heterogeneity, and autonomy. Distribution. Distribution of data in an FDBS federated database system is due to the existence of a multiple DBS before an FDBS is built. Data can be distributed among multiple databases, which could be stored in a single computer or multiple computers. These computers could be geographically located in different places but interconnected by a network. The benefits of data distribution help in increased availability and reliability as well as improved access times. Heterogeneity. Heterogeneities in databases arise due to factors such as difference in structures, semantics of data, the constraints supported, or query language. Differences in structure occur when two data models provide different primitives, such as object-oriented models that support specialization and inheritance and relational models that do not. Differences due to constraints occur when two models support two different constraints. The query language supported by one DBMS can also contribute to heterogeneity between other component DBMSs. For example, difference in query languages with the same data models or different versions of query languages could contribute to heterogeneity. Semantic heterogeneity. Semantic heterogeneities arise when there is a disagreement about meaning, interpretation, or intended use of data. At the schema and data level, classification of possible heterogeneities include naming conflicts, example, databases using different names to represent the same concept; domain conflicts or data representation conflicts, example, databases using different values to represent same concept; precision conflicts, example, databases using same data values from domains of different cardinalities for same data; metadata conflicts, example, same concepts are represented at schema level and instance level; data conflicts, example, missing attributes; schema conflicts, example, table versus table conflict, which includes naming conflicts, data conflicts, etc. In creating a federated schema, one has to resolve such heterogeneities before integrating the component DB schemas. Autonomy. Fundamental to the difference between an DBS and an FDBS is the concept of autonomy. There are four kinds of autonomies addressed. Design autonomy, which refers to ability to choose its design irrespective of data, query language or conceptualization, functionality of the system implementation. Heterogeneities. Heterogeneities in a FDBS are primarily due to design autonomy. Communication autonomy refers to the general operation of the DBMS to communicate with other DBMS or not. Association autonomy gives the power to the component DBS to disassociate itself from a federation, which means FDBS can operate independently of any single DBS. The ANSI, X3, and S-Spark study group outlined a three-level data description architecture, the components of which are conceptual schema, internal schema, and external schema of the databases. The three-level architecture is, however, inadequate to describing the architectures of an FDBS. It was therefore extended to support the three dimensions of the DBS, namely distribution, autonomy, and heterogeneity.
Architecture. The 5-level schema architecture includes the following. Local schema is basically the conceptual model of a component database expressed in a native data model. Component schema is the subset of the local schema that the owner organization is willing to share with other users of the FDBS, and it is translated into a common data model. Export schema represents a subset of a component schema that is available to a particular federation. It may include access control information regarding its use by a specific federation user. The export schema helps in managing flow of control of data. Federated schema is an integration of multiple export schemas. It includes information on data distribution that is generated when integrating export schemas. External schema is extracted from a federated schema and is defined for the users or applications of a particular federation. Over here, we can see the 5-layer architecture of a federated database. When to use federated databases? Distributed operations, lightweight exact transform load, distributed data warehouse, geospatial application. Conclusion. Despite considerable attention from the research community, few commercial database management systems have addressed the problem of integrating relational and non-relational data sources into a federation. With its federation capabilities, IBM has made significant progress towards this goal. IBM's unique federated query processing technology allows users to enjoy all the power of DB2 SQL coupled with the power of individual data sources. It provides users with all the benefits of transparency, heterogeneity, a high degree of function, autonomy for the underlying federated sources, extensibility, openness, and optimized performance. Federation is being used today to solve many important business needs. Thank you.